Now I'm going to explain about equivalence concept in database management systems DBMS. Forget about the writing, focus on the concept and we are going to solve a question. It will help you to understand more easily. So first of all, going into the definition, a set of functional dependencies in F is said to be cover another set of functional dependency E if every functional dependency in E is also in F's closure. That is, if every dependency in E can be inferred from F, alternatively we can say that E is covered by F. I know we can't get at least 0.1% knowledge from this definition. We will do a question, then we can get 100% clarity. So given set F contains A to C, ACD to D, E to AD, E to H, and G set A to CD, E to AH. Find if they are equivalent or not. This is the question. So now we are going to solve the question. If F is covering G or not, we will check this, and if G is covering F or not. If these both satisfy, then F is equivalent to G, or if F is not equivalent to G. Okay. Now F is covering G or not. For doing this, take attribute from G. You should find the closure of A, but in F's functional dependencies. So in F's functional dependencies, you should find the closure. So you can find the closure A to C. Again, we have A, C, D to D, and anything more? Nothing. Okay. So it has A to C, D. It has A to C, D. This is present in. We are finding the closure of A by these dependencies, by F's dependencies, and we found A to C, D. So it is covering. Now find the closure of E, but in F's functional dependencies. So E to AD, and E to H, and yes, it contains EAH. It contains EAH. So this is also covered. So F is covering G. So same like this way we should check in this also. So find the closure of A. Find the closure of A, but take the F this from G. So find the closure of A in G. So A, C, D. Anything more? Nothing. So it has A to C. It has A to C. Done. It is covered. So find the closure of AC now. Find the closure of AC in G. So A to AC. So check here. A to CD. A to CD. Anything more? Nothing. So it has A to D. AC to D. It has AC to D. So it is also being covered. Now find the closure of E. Find the closure of E in G's functional attributes, functional dependencies. So E to AH and A to CD. So we have E to AD. We have E to AD. So it is being covered. And finally check E. Is closure in G's functional dependencies, E to AH, and A has CD. Okay. Now E has H. E has H. E has H. So it is also being covered. So G is covering F. So F is covering B and G is covering F. Therefore it is equivalent. F is equivalent to G. That's it. I hope you understand.